close, light up. Stand by for takeoff.
Power stabilized.
Roger, set up graduating power. 80 knots. V1.
When you're flying an aircraft, everything depends on measurements.
Roger, gear up.
Measurements play an important part here too. The anaesthetist depends on them to help keep his patient alive. As on the flight deck, these measurements need to be reliable, to be as accurate as possible. They could mean the difference between life and death. Measurements are all part of life, and they all call for accuracy in their own particular way. Right from the day you are born, careful measurements enable your growth to be monitored. In the kitchen, measurements like this make all the difference to the success of a favorite recipe. Shopping involves measurement too. Here, it determines how much a thing costs, so it's important to both the buyer and the seller that the measurements are reliable. Whatever you're buying, and however it's sold.
1, 2.
Even on the road, you need reliable measurements to keep within the law. And keeping an eye on the weather calls for yet more measurements. But it's on the building site where you find one of the oldest situations where careful measurement is needed. From the earliest times, people have needed to measure length to build. At first, they used themselves as a measure. A common unit of length was the distance from the elbow to the tip of the middle finger. It was called the cubit. They also used the distance across the outstretched hand, the span. In fact, these are the units in the story of David and Goliath, where Goliath's height is said to be 6 cubits and a span. Other units of length based on man himself include the hand, a unit still in use today to measure the height of a horse. "16 hands. There are other measurements we make today, using our own bodies. But there is a problem. Not everybody's feet are the same length. Human dimensions vary. We need a standard. It's said that in the 12th century, King Henry I decreed that the only lawful standard of length should be the length of his arm. All other lengths were to be based on this. But there was another, more consistent unit of length to be found in nature. It was known that the size of grains of barley varied very little wherever the crop was grown. As a result, they provided a very convenient unit of measure throughout the world. In England, an old unit of length was based on 3 barley corns round and dry. joined end to end. The unit was the inch. But of course, even barley grains vary slightly. It was still not a fixed standard of length. So, in France, about 200 years ago, some scientists decided to base a new standard of length on something in nature that never changed. They chose the Earth itself. The new standard was to be 1/10,000,000th of the distance from the North Pole to the Earth's equator, measured along a line which passed through France and the capital city, Paris. This new standard was called the meter and was represented by a metal bar made of platinum iridium. Near each end of the bar, there's a gold stud. The meter is measured from the center of one to the center of the other. In Britain, the meter has joined other old standards of length like the yard. With the meter came a new standard of mass, also made of platinum iridium, the kilogram. Together, the meter and the kilogram are two of our standard units of measurement in common use today.
Good morning. Can I help you?
Kilogram of mixed sweets, please.
An assortment of these?
Yes, fine.
But can we be sure the measurement shown on this scale has any connection with the standard unit introduced by the French scientists? Is this really 1 kilogram? Well, that's just what John Taylor is about to check. He is an inspector with a local authority, and his job is to go out and check that all measurements used in high street shops are correct. He checked this kilogram of sweets by comparing it with a standard kilogram, one he carries around with him in the boot of his car. According to this, the sweets are slightly more than a kilogram. Lucky for some. But how does he know this kilogram is correct? To check that, it's compared with a reference standard kilogram kept by the local authority. One of a set of reference standards kept for the purpose of checking the inspector's standards. John wears gloves to handle the reference standard, and he makes the comparison on a very sensitive balance, one that will detect really small differences in mass. In this case, it balances. But what if the local authority's reference kilogram is wrong? Here, in a government laboratory, kept locked away, is another reference kilogram. Against this kilogram, all local authority reference kilograms are regularly checked. It's done under very carefully controlled conditions on an extremely sensitive balance. Any small difference in mass is detected by the movement of a light beam, reflecting off a mirror on the balance, onto a scale on the wall. The movement across the scale is noted. But that's not the end of the story. Here, at the National Physical Laboratory near London, the National Standard Kilogram is kept. It's locked away in a cellar under this building. This is our one and only national standard, number 18 in the world. Scientists use this standard only very occasionally to check the one used to check all the local authority standards. The comparisons are done on one of the most sensitive balances made. So sensitive, it has to be enclosed in an airtight cover. The balance is controlled remotely, and any difference in mass is calculated from the movement of the light beam reflected off the balance. But even that's not all. The British national standard and all the other national standards throughout the world are brought here to a laboratory near Paris where the international standard kilogram is kept and where the final comparison is made. This method of checking by comparison means that wherever and whenever you buy by mass, you can be sure the kilogram will always compare with the international one, even that kilogram of sweets. Scientists make similar checks on the meter. They use a reference standard in the form of a metal bar. Against this meter, reference standards from all the local authorities in the country are compared. On these standards, the meter is the distance between two very fine lines near each end of the bar, barely visible to the unaided eye, and only at one particular temperature, something that has to be accounted for during the comparison.
Setting now.
The comparison is done with the aid of a microscope, one at each end.
Towards you.
These can be positioned very accurately over the lines marked on the bar.
That's it.
Like the kilogram, the standard meter kept here is checked at the National Physical Laboratory. But although they have reference standards like this one, they are no longer compared against each other. Instead, scientists use a very important property of light to provide a completely new standard of length on which the meter is now based, and against which reference bars like this one are now compared. It's done in a light-proof, airtight box in which conditions can be carefully controlled. The apparatus used is the only one of its kind in the country. It enables scientists to check the length of the bar in terms of light more precisely than ever before. Interpreting what he sees, though, is a highly skilled job. Light is also used for measuring long distances very precisely. It's a particular kind of light, one that comes from a laser. These men from the Ordnance Survey, the map makers, are using the laser to check the distance between one of these fixed points, you may have seen, and the site of what will eventually be a new one. Directly above this point, there's a reflector. This returns light from the laser back along exactly the same path as it has come. As the beam is collected, it's converted into electrical signals from which the operator can calculate the distance very precisely.
8631.
8631.
8656.
8656. OS20 to OS21. Can I have your Met, please? Over.
But, like all other measurements of length, the weather can affect the results.
17.5 dry, 13.0 wet. Over.
Dry 17.5, wet 13.0, 755.9. Over.
The weather readings will be used to correct the distance measured by the laser to provide a very high degree of accuracy needed by map makers. But then accuracy is needed in many areas today, and there are many new measuring devices apart from the laser. This device is being used to check the dimensions of a component for a new aircraft. The distances are measured by moving a metal probe from point to point. Each time it touches the component, its position is recorded on a typewriter. To make sure the measurements are accurate, the device is checked every morning using a standard reference bar. It's well within the required accuracy. Just as well, the new aircraft's safety could depend on it. In fact, its safety depends on many more measurements, both in the air and on the ground. A knowledge of the weather is essential for the captain of any aircraft. Here at Heathrow Airport, weathermen make regular observations at half-hourly intervals. As well as temperature, there's atmospheric pressure, wind speed and wind direction. And all this information is logged and passed on to the control tower in the form of a special code. On these measurements depend the safe landing of the next plane.
Five 17, appearance after landing, clear to land 28 right, wind 290 degrees, 12 knots.